So now that you heard about the exciting side of chemical engineering, now you get to hear about our very exciting side. So we have some fantastic students all ready to show you their projects they're working on. So these are in-class projects. And actually up first we have Jordan Miner, who's here with some examples and her super hand.
Hello everyone, my name is Jordan Miner. I am a senior this year. My major is biomedical engineering, but I also have a double minor in electrical engineering and bioinstrumentation. So this project we did my junior year. This was my hand. So this is our Iron Man hand. So what each group does is they pick a theme. So clearly my theme was the Iron Man, but there are a lot of different themes chosen here. And they do this for a purpose. So what we wanted to do was empower young kids to feel like a superhero, even though they've lost part of their hand. So some functionalities includes, we have a little SD card, which is loaded with a bunch of Tony Stark's audio clips, and they can play those with these buttons. And we also have a little laser, as well as our little Iron Man hand here with some fabric you can take out in machine wash. So it just activated using simple wrist activation. Some other ones that we have this one allows you to use your cell phone with it, and it also has a temperature and pressure sensor. And each one is kind of designed with their own theme in mind, and each group kind of takes an individual spin on it.
Some of our other projects is we make a small inline IV mixer. So we need to mix two fluids together. It needs to be able to be small, disposable, economical for different uses. So we design this, they print it and they test it. So we have Evan here, who's all set and ready to actually show his mixer in action. So you can see where we have two colored fluids. We have yellow and blue moving together, and in the mixer we can see it actually mixes quite quickly, and we end up with a nice pretty green at the end, showcasing that the mixer is actually doing its job and doing it very well.
Yes. So after you get through those labs, what's next? Well, we have to cap it off with something, and that's what we're going to do. We're going to walk down the hallway into our special capstone room, and I'm going to introduce Liza White for you. She's going to talk a little bit about her capstone project that she's working on.
This year, my capstone is working with rescue situations. So last year, they used aviation to look at rescue situations of finding patients in the air, and they wanted to see how the pilot stresses were indicated, so that works on like their heart rate and if there's sweat on their skin. This year though, we're working on the ground situation, which is more patient driven. So what you see here is a Stokes basket. This is typically what a patient is in. And then from the Stokes basket, they go into a rescue sled that is towed by a snowing machine. And with this, we're working on trying to get more patient care so that the providers can transport the patient and treat them at the same time. So we're really looking at adding vitals to this, and it's a great opportunity for me to intermix my EMS experience as I work as an EMT at UVAC, which is a ambulance service on campus. And I get to take that experience and work with my teammates to hopefully make an awesome product.
Thank you, Liza. We're going to move down the hallway a little bit and talk more about real-world opportunities that are also afforded to our students, primarily through the form of research. So in biomedical engineering education, undergraduate research is a little bit more important than maybe other engineering disciplines. And because of our small size, we have the ability to offer and afford undergrad to faculty direct interaction in the research labs. So I'm going to have you turn around and I'm going to introduce Jordan Miner, who's been a Maine top scholar, and she's been in my research group since her freshman year, and now she's a senior. And I won't spoil the surprise about what her plans are for the future.
This right here is actually my poster that I've done 3 years of research on. So the University of Maine has allowed me to do research all 4 years, which is amazing. I've learned so much from this experience, and that actually helped me get 2 internships, one at IDEX and one at NASA. So there's so many different opportunities that the University of Maine offers. So my poster here, what we did is we used second harmonic generation imaging, and we imaged zebrafish with Duchenne muscular dystrophy. So what we were trying to do is see how strength training interfered with the muscle structure. So we did is we stimulated them with electrical stimulations that mimic different types of exercise. And what we actually found was that if you mimicked endurance strength training, it increased the sarcomere distance, which are the fundamental units of a muscle. And so that means we think that endurance strength training may be a huge breakthrough in determining the exercise regimen a person with Duchenne muscular dystrophy should do to improve their condition, since there is no cure. Again, this research is still ongoing, and I'm just really excited to have been a part of it for the last 3 years.